Okay, let me start. Um, Let me review a little bit about the queue. So we learn about queue. Yeah, this problem appeared in the mid exam. Yeah, as I mentioned to you, if it is the content of a list or array, then you should write with the square bracket. Okay. So if we have n cube 5, then it means the content is 5 and it is inside the square bracket. So we learn how to apply Q with array. Array means it is a data structure and we have a size. So the size usually it is already determined. The size already fixed. And if we want to expand, yeah, we can add more space. Or if we want to remove, then we can remove some space. So we have an array, and let's say this is a place with n. This is an array with n size. And we are going to have a circular patient. Circular patient means once we finish with this one, let's say the last value is in this position or in this index. So we can start again from the beginning. So we call this is a circular fashion because we want to keep the size n, and then we will do the wrap around configuration. If the index already at the position of n, we will put the additional content or the starting from index 0. So you can think this is a kind of restaurant. If a restaurant, there will be a capacity. So let's say the restaurant is suitable for 50 people. Then the size will be 50. So if there are more than 50, then the person or the guest or the client should be in the waiting list. So if it is in the waiting list, also in the waiting list, there will be some capacity. Then yes, we will do that kind of thing with Q. So in this array-based Q, we have two variables. The two variables is to indicate where is the front element and then where is the rear element. Array location R is kept empty. So the position R is empty. We know that in Python, whenever we use range, range 0,5, what does it mean? It will be number from 0, 1, 2, 3, 4. It is always the last number minus 1. Then this is also the same. We have the last index R and we want to put this as empty. So the index will be always until the R minus 1. Okay. That's why whenever we want to know the size, okay, so let's say now there are there is one element in the index 0. There is one element in index 1, there is one element in index 2, and so on. The Q in the index 0 now The Q in index 0, there is one element in index 0, and then it is DQ, or we remove the Q. There is an element in index 1, and then we DQ, or remove the element. We have another element, and then we remove that. We have another element, and then we remove that element. So we have another element here. We have another element. We have another element. We have another element, and so on. So now the element in the queue are in the pink area. So we can just put the front is here. Whenever we want to remove the element, so we will start from the front. And the rear means the last element. In order to find out the size, okay, you already know this one. This is one from mid-exam. In order to find out the size, we can use this formula n minus f. F is the front element. R is the rear element. And we will do the modulo operator, modulo by n. So you know this is an example. If we have n equals to 17, and we know f is 4, 0, 1, 2, 3, 4. And then r is in the 14. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can calculate the size just putting every number here. So n there are 17. So 17 minus front, which is 4, plus 14, which is rear. The result is 27. And we know that we need to do the modulo with the n, which is 17. Then 27 mod 17, it equals to, we have 10. Okay. So the size is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there are 10 elements in the queue. Okay. If we use the wraparound, then we have the n equals to 17. Now the position of f is here. It means every element here, it is already removed. So all the elements already move out from the queue. Now the element remaining here, 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 and here, but there is no other space. Because no other space, so the new element will go back to the element in the index queue. And then we start again to fill in the element here, 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 and so on. So this is the wraparound configuration. And we will check what is the size of this queue. We know that this is the F, the front, it is 11. And then we know the R is 4. Then we can calculate the size. 17, this is the N, minus by the front, which is 11, and then plus with 4, which is the rear. So we will get the result is 10. 10 modulo 17. 10 modulo 17. The result is 10. Okay. You can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 elements in the queue. we can calculate, we can know whether the queue is empty or not. If it is empty, it means the front equals to the rear. Then there is no element in the queue. So what is the operation? You know that every data structure will have the operation insert and remove. Insert means we want to input the element into the array or into the data structure. So we have enqueue. Enqueue means we want to put this element into the queue and we want to put this object. So this object can be anything. It can be number, it can be string. So the operation enqueue throws an exception if the array is full. Okay. Because we already know that this array contains only n size. Then we need to give an exception. This is the exception. If the size is n minus 1, okay, the size, it means we call the function here. If the size equals to n minus 1, then do the exception. So we cannot put any element in the queue. But if the size is not equal to n minus 1, let's put the object O into the queue with the R position. R position is the rear. And then the rear position R will be updated. How we can update the R? We will do with addition R plus 1 and we will do with mod n. Why? We need to do with mod n because when R is here, what happens? If the next new element is inserted into index 0, then the next R will be here. If we keep R plus 1, R plus 1, R plus 1, then it will be exceeding the value. So in order to keep the value in between 0 until 17, so we do with the mod. So for example, R. Let's say the R now is 14. The R now is 14. Then the next R is 15. So R is 14 plus 1, which is 15, mod 17. 15 mod 17, it is 15. So there is no change. This is still in the range of the array. But let's say now we have the R is 4. So if the R is 4, we will do the addition with 1. 4 plus 1 mod n. N is 17. So 5 mod 17, it is 5. How about if the R is here? If R equals to 17. Oh, sorry. There is no 17. R equals to 16. If R equals to 16, then R plus 1, it is 17 mod 17. 17 mod 17, it is 0. then the R is in the index queue because the last element is inserted into the last index. Okay. How about DQ? So in the DQ, whenever we want to remove an element, we will do something. We will throw an exception if the queue is empty. So we will check. If the queue is empty, then we can make an empty queue exception. If it is not empty, then let the object O equals to the front queue at the index F. It means the queue at the index of the front. And we need to update the front. F. If we remove this one, then F will be plus by 1. If we remove this one, then F will be added by 1. And so on. So if F is added by 1, then we also need the mod N. Because when F is here, we cannot go next. Because the size is limited. The size is only N. That's why we have the mod N to make this value back from 0. And then we want to know what is the object that we did. So there will be an exception. So we can make a kind of exception. The exception is empty queue, and the other exception is the full queue. So last time we learned about the exception in the first part of Python. So in queue, okay, if you go to the code, okay, there might be 3 instance variables. So data, size, and front. Data means a reference to list instance with fixed capacity. Size means an integer representing the current number of elements stored in the queue. And then front is an integer that represents the index within the data of the first element. So we learned previously, if we have this underbar, then it is considered as a private data member. Okay. The private data members means we will not be able to access from outside the class. So the author of the book gives the queue code. We can make an array of queue. So we have a default capacity. Let's assume the capacity is 10. We can make the constructor. So the constructor will create the initial data. The initial data, everything will start with none. Do you understand this one? None multiplied by array q dot default capacity. So it means we will do none for 10 times. So here we will do none for 10 times. What is the result? The result is none, none, none until 10 times. Okay. So every element in the initial array will be null. And then we have the size is 0 and the front is 0. So if we make the first array, this is the first column. We can return back the length. So the length is the size. And then if it is empty, yeah, the size is 0. We want to know what is the first element. So the first element means it is the element at the index front. So if it is empty, then we can just call the empty exception. So the queue is empty. But if it is not empty, then we will call the data and we call the index front. What about the queue? So we have the queue again, like what we saw before. We check whether it is empty or not. If it is empty, then we will do the exception. If it is not empty, then the answer will be the queue, means we want to remove and return the first element of the queue. So you know the queue is FIFO, first in, first out. So we will remove the front. So some of the students confused between front and last. So if we have 5, 3, 7, 9, 4, what is the front? The front is 5. Okay. So when we say DQ, it means we will remove the index 0. Okay. So this is Q. But if we use stack, when we want to remove the element, we use pop. What does it mean by pop? We will remove the last element, or we want to remove the end of this array. So that's the difference between Q and stack. We get the front, and then the data at the location front will be none. And then we update the front plus 1, and then we do the modulo. The modulo is, we want to get the n. In this case, yeah, we just update the size every time we have dq or q. So this is nq. NQ means we want to put a new element into the list. We want to put the new element into the queue. So we need to check the size. What is the size? The size of the array should be at least the same with the size of the list. If the size is the same with the data in the list, then double. So we learn two strategies for the growable array. What are they? The first is incremental strategy, and the other is doubling strategy. If it is an incremental, then we will add by 1, 1, 1, 1. But if it is a doubling strategy, we will multiply by 2. Multiply by 2. So based on the analysis, doubling strategy is more efficient than the incremental strategy. So this is the way to do the doubling printing. You just multiply the length of the data with 2. So if it is not the same, yeah, we can just do directly the available means the location or the index. The index is front plus size modulo length. Then we will put E, which is the element, into the index in the available position. And the size will be 8. Now let's look at the resize. The resize here means a method or a function, and we have one parameter which is cap, or we call this is the capacity. So we want to resize the array with this formula. So this formula will be the variable of capacity. So we will just update the capacity of the array. It means we want to know the data, and we just put the data into a list. And then we make the data with new known according to the new size, which is the capacity. So let's say if the capacity is 10. Okay, so the capacity is 10. So it will be 2 multiplied by length of the data. So 2 multiplied by 10. 2 multiplied by 10, it means 20. So the value 20 will be in the variable capacity. And the new data will be a variable with known multiplied until 20 times. So there will be known until 20, because we already calculate with 2 multiplied by the length of data. What? So we want to find every of the element. The walk will start from the front. And then we do the for loop. Let K be an index from 0 until the size. The size means the size of the cube. So every data in the walk, every data in the old in the position of walk will be saved into the data in the position of K. And then we will update walk with walk plus 1 modulo the length of all data. Let's update the front goes to 0. Then we finish to resize here. I will skip this one. This is a kind of simulation. In the simulation, there is one problem about the round robin schedulers. So let me skip this one. If you have interest about the round robin schedulers, the round robin schedulers use queue. Okay, so that's about the queue. Now let me move to the next section, which is about linked list.